LTC2440 High-Speed Delta Sigma Analog to Digital Converter Linear Technology. Welcome to this training module on Linear Technology's LTC2440 High-Speed Delta Sigma Analog to Digital Converter. This training module introduces the internal architecture of the LTC2440, its basic operation, and its key features. The LTC2440 is a high-speed, 24-bit, no-latency delta sigma analog to digital converter with 5 parts per million integrated nonlinearity and 5 microvolts offset. It uses a proprietary delta sigma architecture enabling variable speed and resolution with no latency. 10 speed resolution combinations are programmed through a simple serial interface. Alternatively, by tying a single pin high or low, a fast or ultra-low noise speed resolution combination can be easily selected. The accuracy and power dissipation are independent of the speed selected. Since there is no latency, a speed resolution change can be made between conversions with no degradation in performance. Following each conversion cycle, the LTC2440 automatically enters a low-power sleep state. Power dissipation may be reduced by increasing the duration of this sleep state. The LTC2440 communicates through a flexible 3-wire or 4-wire digital interface. The LTC2440 is a high-speed delta sigma analog to digital converter with an easy-to-use 4-wire serial interface. The 4-wire interface consists of serial data input, serial data output, serial clock, and chip select. The interface, timing, operation cycle, and data out format is compatible with the LTC2410. The serial data input pin is used to select the speed resolution of the converter. During the data output period, the serial data output pin is used as a serial data output. During the conversion and sleep periods, this pin is used as a conversion status output. The voltage on the differential analog pins can have any value between ground and negative 0.3 volts and VCC plus 0.3 volts. Within these limits, the converter bipolar input range extends from negative 0.5 to 0.5. Outside this range, the converter produces unique overrange and underrange output codes. The LTC2440 can accept a differential reference voltage from 0.1 volts to VCC. The LTC2440 performs offset and full-scale calibrations every conversion cycle. The advantage of continuous calibration is extreme stability of offset and full-scale readings with respect to time, supply voltage change, and temperature drift. The LTC2440 transmits the conversion results and receives the start of conversion command through the synchronous 2-wire, 3-wire, or 4-wire interface. During the conversion and sleep states, this interface can be used to assess the converter status, and during the data output state, it is used to read the conversion result and program the speed resolution. The serial data input pin is used to select the speed resolution of the LTC2440. A simple 2-speed control is selectable by either driving the serial data input high or low. If serial data input is low, the device outputs at 880 Hz with 21 bits effective resolution. By tying serial data input high, the converter enters the ultra-low noise mode of 200 nanovolts RMS and simultaneous 50 and 60 Hz rejection at 6.9 Hz output rate. Serial data input may also be programmed by a serial input data stream under control of S-clock during the data out cycle. One of 10 speed resolution ranges from 6.9 Hz, 200 nanovolts RMS to 3.5 kHz, 21 microvolts RMS may be selected as shown on the table. The conversion following a new selection is valid and performed at the newly selected speed resolution. Initially, the LTC2440 performs a conversion. Once the conversion is complete, the device enters the sleep state. While in this sleep state, power consumption is reduced below 10 microamps. The part remains in the sleep state as long as CS is high. The conversion result is held indefinitely in a static shift register while the converter is in the sleep state. Once chip select is pulled low, the device begins outputting the conversion result. There is no latency in the conversion result. The data output corresponds to the conversion just performed. This result is shifted out on a serial data output pin under the control of the serial clock. Data is updated on the falling edge of S-clock, allowing the user to reliably latch data on the rising edge of S-clock. The data output state is finished once 32 bits are read out of the analog to digital converter or when chip select is brought high. The device automatically initiates a new conversion and the cycle repeats. The LTC2440's 2-wire, 3-wire, or 4-wire interface is SPI and microwire compatible. This interface offers several flexible modes of operation. These include internal and external serial clock, 2-wire or 3-wire I/O, single cycle conversion, and auto start. The LTC2440 serial output data stream is 32 bits long. The first 3 bits represent status information indicating the sign and conversion state. The next 24 bits are the conversion result, most significant bit first. The remaining 5 bits are sub-least significant bits beyond the 24-bit level that may be included in averaging or discarded without loss of resolution. In the case of ultra-high resolution modes, more than 24 effective bits of performance are possible. Under these conditions, sub-least significant bits are included in the conversion result and represent useful information beyond the 24-bit level. The third and fourth bit together are also used to indicate an under-range condition or an over-range condition. During the conversion cycle, the LTC2440 draws 8 milliamp supply current independent of the program's speed. Once the conversion cycle is completed, the device automatically enters a low-power sleep state drawing 8 microamps. The device remains in this state as long as chip select is high and data is not shifted out. By adjusting the duration of the sleep state, by holding the chip select high longer, and the duration of the conversion cycle by programming the OSR, the DC power dissipation can be reduced. One of the advantages delta sigma analog to digital converters offer over conventional ADCs is the on-chip digital filtering. Combined with a large oversampling ratio, the LTC2440 significantly simplifies anti-aliasing filter requirements. The LTC2440's speed resolution is determined by the oversample ratio of the on-chip digital filter. The oversample ratio ranges from 64 for 3.5 kHz output rate to 32,768 for 6.9 Hz output rate. The value of oversample ratio and the sample rate Fs determine the filter characteristics of the device. Since the oversample ratio is typically large, greater than or equal to 64, the digital filter offers excellent rejection of input noise sources and simple anti-aliasing requirements. Programmable gain amplifiers are commonly used in systems where small input voltage needs to be applied to a wide input range analog to digital converter. The convention is to amplify the sensor output voltage range so that it matches the analog digital converter input range. However, the system performance is dominated by the noise performance of the programmable gain amplifier as well as its offset, full scale, and linearity performance. Programmable gain amplifiers degrade system performance by introducing added error sources, drift, cost, and complexity. Eliminating the programmable gain amplifier requires a converter with exceptional offset, linearity, full scale accuracy, drift, and noise performance. The converter requires enough resolution over its full input range to maintain high resolution within a significantly reduced portion of its input span. This allows system designers to directly interface sensors to the analog-to-digital converter while using a small portion of the overall converter input range. The exceptional noise performance of the LTC2440 allows the user to make one conversion with 500,000 counts and no DC errors for any plus or minus 50 millivolt range. If the analog-to-digital converter can be located physically close to the sensor, it can be directly connected to sensors or other sources with impedance up to 350 ohms with no other components required as shown in the figure. If longer lead lengths are unavoidable, adding an input capacitor close to the analog-to-digital converter input pins will average the charge pulses and prevent reflections or ringing as shown in Figure 2. Many applications will require buffering, particularly where high impedance sources are involved or where the device being measured is located some distance from the LTC2440. The figure shows a network suitable for coupling the inputs of an LTC2440 to an LTC2051 chopper-stabilized op-amp. The 3 microamp offset and low noise of the LTC2051 make it a good choice for buffering the LTC2440. The LTC2051 is configured to be able to drive the 1 microfarad capacitors at the inputs of the LTC2440. The 1 microfarad capacitors should be located close to the analog-to-digital converter input pins. Here lists 3 items for selecting a suitable amplifier as a buffer. Running with an external oscillator of 100 kHz and the highest resolution, the RMS noise of the LTC2440 is 200 nanovolts over a full plus or minus 2.5 volt input range. 6 decades of current in either direction can be measured accurately through a 1 ohm resistor independent of low-frequency system noise. The flexible common mode input range enables the LTC2440 to digitize these signals near VDD. The LTC1799 is a precision oscillator whose frequency is programmed by a single external resistor. The LTC2440 offers accuracy, stability, and ease of use that are common to the LTC2400 product family. It combines a programmable, oversample ratio digital filter with a high-speed analog modulator in order to achieve high speed and accuracy independent of output rate. The LTC2440's wide range of user-programmable speed and resolution combinations makes it flexible enough to fit in a wide variety of applications.